In this video, we're going to be looking at how our understanding of what atoms are and how they're structured has changed over time. We'll consider several models of the atom that were proposed throughout history, and eventually we'll look at the currently accepted model of the atom, which we have to know for GCSE. We'll also briefly look at how this currently accepted model is evolving, and look at what our understanding of atoms may be like in the future. You need to learn this timeline. The idea of the atom was first proposed over 2,500 years ago by a Greek philosopher called Democrities. He proposed that everything in the universe was made up of small, indivisible units called atoms. His idea was met with skepticism by other Greek intellectuals, including Aristotle, who believed, like the majority of Greek philosophers at the time, that everything physical was composed of the four natural elements: earth, fire, water, and air. While Aristotle was no doubt a brilliant intellectual, these ideas would have perhaps made more sense in a children's cartoon. Over 2,000 years later, a scientist by the name of John Dalton proposed that atoms are in fact solid spherical objects. He proposed that different elements are made of different types of spheres, and that these different spheres have different properties and different masses. You can see here some of his ideas of what atoms should look like. The next step in the evolution of our understanding of the atom was provided to us by J.J. Thomson. He said that there was no concentration of positive charge in one place in an atom, but that the positive charge was spread out evenly throughout the structure. He suggested that atoms were a ball of positive charge with electrons stuck inside it, similar to a plum pudding. Now, as nobody's eaten a plum pudding for 100 years, a more up-to-date analogy would perhaps be that of a chocolate-chipped cookie, where you can assume the dough of the cookie is the positive charge spread out throughout the whole structure, and the individual chocolate chips are the individual electrons. This plum pudding model is what we call a hypothesis. It's a possible explanation of something. In order for us to test the hypothesis, we need to make a prediction based on it and see if our prediction comes true from experimentation. If the evidence from the experiment supports our prediction, then we're one step closer to figuring out if our hypothesis is true. In order to determine whether the plum pudding hypothesis is accurate, an experiment was conducted by Ernest Rutherford and his student Ernest Marsden, called the Alphaparticle scattering experiment. Rutherford and his student performed the alphaparticle scattering experiment to test the plum pudding hypothesis. The experiment involved firing a beam of positively charged particles, called alpha particles, which you may know from physics are a group of 2 protons and 2 neutrons, at a thin sheet of gold foil. If the plum pudding model was correct, and the positive charge was spread out evenly throughout the atoms that make up the gold foil, then the alpha particles would pass straight through the foil, as there is no concentrated positive charge to repel them. However, this is not what the experiment found. The experiment found that some of the alpha particles did pass straight through the foil. However, some particles were deflected, and some particles were even sent back the way they came, as if they had just struck a particle much heavier than themselves. Rutherford is quoted to have said that this was as remarkable as firing a 15-inch shell at a piece of tissue paper and it coming back to hit you. The reason some alpha particles were deflected was because they must have encountered a concentrated area of positive charge. So there must be concentrated areas of positive charge in an atom, contrary to the plum pudding model. The fact that some particles deflected back in the same direction they came suggested that this region of concentrated positivity must be extremely heavy. And the fact that a lot of alpha particles still managed to pass through suggests that this heavy, concentrated area of positive charge must be very small, so it's easily avoidable. One extra thing you may need to know is that gold was used as it can be turned into a foil only a few atoms thick. The experiment by Rutherford and his student led to the refutation of the plum pudding model. Rutherford used the fact that atoms must contain a small, heavy, concentrated area of positive charge to create his nuclear model of the atom. This model assumes a positively charged nucleus that is extremely dense. This model also assumes that electrons exist as a cloud of negative charge around the central nucleus. This model is better than the plum pudding one, however it has one major flaw. There was nothing stopping the electron cloud in this theory from falling into the positive nucleus and causing the atom to collapse. Obviously, we know that this does not happen, so this model must be wrong too. In order to deal with the flaws of the nuclear model, Niels Bohr came up with the concept of electron shells in 1913. Bohr proposed that electrons orbit the nucleus in fixed shells and cannot be found in between shells. This idea became widely accepted as it was supported by the work of numerous other scientists at the time. Rutherford then discovered that the positive charge in the nucleus comes from protons, and 2 decades later, James Chadwick discovered the existence of neutrons. This updated nuclear model is the currently accepted model of atoms, and this is as far as you need to know for GCSEs. For those of you who are really curious and want to go beyond the GCSE and even A-level specification, this is the current model of the atom we're working on, the quantum mechanical model. It requires ideas from some of the greatest scientists of all time, Planck, Heisenberg, and Schrödinger. Although this guy may be the most famous Heisenberg of the last decade, he isn't the one we're talking about. We're talking about this guy. Now we've got the correct Heisenberg, we can briefly speak about this model. The quantum model is based on what's known as the Heisenberg uncertainty principle, which tells us that it's impossible to know both the exact position and speed of an electron at the same time. It also uses the fact that electrons can behave as both waves and particles, and makes use of the Schrödinger equation. Have a Google or something if you're really interested, or ask your teacher to see them squirm. Anyway, here's what an atom of hydrogen actually looks like, with a picture taken by a quantum microscope. If you guys enjoyed the video, please make sure to subscribe, comment and like. If you feel like you know someone who can really benefit from watching this, please share it with them.